Okay. Adi. Okay. So see. So next topic is relation between rotational kinetic energy and angular momentum. So we studied about angular momentum nama. So linear momentum multiplied by perpendicular distance from the axis of rotation. Are rendu multiply chesthe we get angular momentum. Clear? Now we are trying to derive a relation between rotational kinetic energy and angular momentum. Directly also we can derive, but we will try to derive with the help of analogy. Analogy తీసుకొని derive చేద్దాం. What is meant by analogy? So in linear motion, we know that kinetic energy is equals to half mv square normal. This is the equation for kinetic energy in linear motion. Okay. Similarly, what is the equation for linear momentum? Mass into velocity. Are you able to understand? So if I divide both of them, then I will get k is equals to p square divided by 2m. This is the relation which I will get. Okay. K is equals to p square divided by 2m. This is one relation. Are you able to understand? Same equation, can you say how can I write in rotational motion? Same equation, how can I write in rotational motion with the help of analogy? K. What is meant by K? Kinetic energy. In which motion? Linear motion. So instead of K, again I will write Kr. Kinetic energy in rotational motion. That's all. No? And what is meant by P here? P is called linear momentum. In rotational motion lo em raskuntam. L, instead of P I will write L square. That's all. No? So divided by 2. M means what? M means mass, no? Which is the reason for inertia. If mass is greater, inertia is also greater. And instead of M, here what I have to write? I, moment of inertia. So this is the inertia in linear motion, this is the inertia in rotational motion. So like this, by analogy also you can remember. Are you able to understand? Or you can write equation K is equals to half I omega square. Okay, ma? Then L is equals to I into omega. Then you divide both of them. Again you will get the same relation. Okay. Just here we are trying to write the relation by using what? By using analogy. Are you able to understand? Ma? So K is equals to L square divided by 2y. That is the equation. Clear? That's it. Make a note of this. Okay, ma? So see this problem. So find angular momentum of a particle about point O of a particle of mass m moving with the velocity v parallel to x-axis at a distance of d. Okay, ma? Mass of the particle is how much? M. So it is moving parallel to x-axis. Are you able to understand? Ma? Towards positive x-axis it is moving. And at what distance it is moving? It is moving at a distance of d. For this condition, first of all, we are supposed to calculate angular momentum. Then we will see the second condition. Okay, ma? So see the first condition. So where is the position of the particle, ma? So this is positive x-axis, no? So particle is moving along positive x-axis at a distance of d from the x-axis. It means let us consider particle is somewhere here. Okay, ma? Mass of the particle is m. And it is traveling with how much velocity? It is traveling with a velocity of v parallel to x-axis. Parallel to x-axis means like this only, no? It is traveling like this. And it is located at how much distance, ma? It is located at a distance of d from the x-axis. This is the question. Okay, ma? So particle is moving like this. So for this particle, can you say how can I calculate angular momentum? L value, how can I calculate? Can you say? Angular momentum, how can I calculate? You want to calculate with the help of k into k square by 2i. What is the kinetic energy of this particle? Half mv square. Okay. So what is the angle k square by L square by 2i? Angular. Okay. You want to calculate with that formula. Okay. Definitely you can calculate. Are you able to understand? Any other method? So first method is, we have already studied that rotational kinetic energy is equals to k is equals to L square divided by 2i. Okay. So this particle, is it rotating? Ma? It is not rotating, no, it is moving in a straight line. Okay. But this is the equation for rotational kinetic energy. This is the equation for what? This is the equation for rotational kinetic energy. Are you able to understand? It is not rotating. This formula we cannot use. Any other formula? Any other formula? Ma? So angular momentum is equals to mvr. This formula is also there, no? When it is moving with a tangential velocity of v, then L is equals to m into v into r. This formula I can use definitely. Are you able to understand? So mass of the particle is how much? M. What is the speed, tangential speed of this particle? V. And what is meant by r here? R means what? Which distance? Perpendicular distance. See, to define angular momentum, there should be some axis of rotation, no? What is the axis of rotation? About which point he is asking? He is asking about a point O, no? Are you able to understand? Ma? It means this is my axis of rotation. Okay. So from this axis of rotation, what is the perpendicular distance? Perpendicular distance is d only. This becomes the total distance. But I am not concerned about this distance. No? I am always concerned about perpendicular distance from the axis of rotation. Perpendicular distance is already given, no? D. So m into v into d. That is my formula. Are you able to understand? No? So this is the equation for angular momentum in this condition. Okay. Now the question is, angular momentum, is it a scalar quantity or a vector quantity? Angular momentum, is it a scalar quantity or a vector quantity? Vector quantity. So therefore, how can you find out the direction of angular momentum in this condition? How can you find out the direction of angular momentum in this condition? How? Direction, he may ask the direction. 1 minute. Seema, the direction, the representation of angular momentum in vector form. So L dash is equals to R dash cross P dash. This is the formula which we have written, no? L dash is equals to R dash cross P dash. What is meant by P here? Momentum, mass into velocity. Momentum is mass is a scalar quantity, no? You can take it outside. So R dash cross M into V dash. I can write like this also. Okay. So mass, you just take it outside because it is a scalar quantity. So R dash cross V dash. So this is the equation of angular momentum in terms of vector form. Okay. Now first vector is R dash, no? So place your right hand on R dash. Clear now? Which is my second vector? Second vector is V dash. So V dash is in this direction, no? So rotate towards V dash. Are you able to understand? Ma? So first vector is in this direction, no? This is the direction of first vector, R dash. Okay. Second vector is in this direction. Okay, velocity vector. So place your right hand on first vector, rotate towards the second vector. What is the direction of thumb? Ma? Thumb is perpendicular and it is inside the board. So what is the axis present inside the board? Z axis. Positive Z axis or negative Z axis? Negative Z axis. So therefore, how can I write this equation? So therefore, angular momentum is equals to, clear ma? So mvd minus k cap, that's all. Just I can write like this. Okay. Minus k cap represents it is towards the inside of the board and perpendicular to the board. Clear number? So therefore, L dash is equals to minus mvd k cap. So I can write like this. Are you able to understand? That's it.
Sir, velocity minus k z dash minus z dash velocity then v naught square by 2.
కాదు. Okay, ma? So let us see this problem. Ma? A particle of mass m is thrown with a speed v naught at an angle of 30 degrees with horizontal. Clear now? It means the question is that particle is thrown like this. That's what he is trying to say, no? Mass of the particle is m. And what is its initial velocity, ma? Initial velocity is v naught. Okay? At what angle? At an angle of 30 degrees with respect to positive x-axis. Then what this body will do? This body will trace a parabolic path, no? Ma? Any body traces a parabolic path. Okay? So this body is also tracing this kind of path. Find the angular momentum about the point of projection. So I want angular momentum about this point. Clear? Where when the particle is at the highest point of trajectory. After some time, body will reach the highest position, no? So when it is present at h max, when it is present at this position, maximum height, we are supposed to find out angular momentum. That is the question. Okay. So angular momentum formula L is equals to m into v into r only, no? So write down mass of the particle is m. Velocity of the particle is how much?
0.
Abba.
0. H max at the velocity 0.
Expect చేశాను నేను అదే చెప్తారని, కానీ అది కాదు. See, at the highest point, particle will have how much velocity? Highest point దగ్గర అంతే అంటావు అయితే. ఫిక్స్ అయిపోయింది ఆన్సర్ అదే అని. సీమ Sima, at the highest point, particle will have only horizontal velocity. Already we studied nearly 1000 times. Clear now? What is the total velocity of the particle? Total velocity of the particle is v naught. Split this v naught into two components. This is 30 degrees, no? So this is v naught cos 30 and this is v naught sin 30. So this is the velocity along x-axis. This is the initial velocity along y-axis. So at the highest point, this total velocity will become 0. Velocity at the highest point will be 0. But which velocity? Vertical velocity will be 0. But horizontal velocity you can never change, no? This velocity can never be changed. Already we studied, no? Horizontal velocity of the particle never changes. It is always a constant. But when particle travels from here to here, vertical velocity continuously decreases. At the highest point, final velocity along y-axis will be how much? 0. Y-axis paina unna velocity 0 avutundi. But what about velocity along x-axis? Velocity along x-axis remains to be ux, which is equals to v naught cos 30. Already we studied, no? This velocity never changes. So even at the highest position also, particle will have how much velocity? V naught cos 30. చదువుకున్నామా లేదా? Okay. So therefore, instead of velocity, what I am supposed to write? V naught cos 30 multiplied by r. Now what is meant by r here? R means what? Perpendicular distance to velocity from the axis of rotation. Ante kada. So perpendicular distance to the velocity from the axis of rotation is nothing but h max. H max is the perpendicular distance, no? So substitute h max. So multiplied by h max. Okay. And what is the equation for h max? U square sin square theta divided by 2g. So substitute. So m v naught cos 30 multiplied by u square sin square theta, no? So v naught square sin square 30 divided by u square sin square theta divided by 2 into g. 2g. That is the equation for H max. Now just simplify this one. So m v naught cos 30 value is root 3 by 2 multiplied by v naught square multiplied by sin 30 value 1 by 2. So 1 by 2 whole square is 1 by 4 divided by 2 into g. That's all now. So therefore, now substitute. So m v naught cube multiplied by root 3 divided by 2 into 4g. Okay. So root 3 m v naught cube divided by 4 2s are 8, 16g. So that is my answer. Are you able to understand? Again, if he asks you the direction, what will be the direction? Direction of angular momentum. Again same, r dash cross p dash. It is present towards negative z axis. Clear now? So therefore in vector form how can I write? L dash is equals to, I can directly write minus root 3 m v naught cube divided by 16g multiplied by k cap. That is my answer. Okay. Now see this question. See ma, two balls, they are attached by a light rod. Masses are 2m and m. Clear ma? Light rod means what? Light rod means it is not made up of light energy or heat energy or sound energy. Light rod means mass of the rod you need not consider. Mass is very less, you need not consider. Clear now? And this system is rotating about an axis perpendicular to the rod and axis passing through center of mass of the system. It means first of all I am supposed to calculate what? I am supposed to calculate where is the center of mass of this system. Without a center of mass I cannot do this problem. Okay, ma? Then about that axis what will be the angular momentum that I want to calculate. Clear? Okay. So first of all, see ma, this is a two particle system. Any particles unna ikkada? Two particle system. And for two particle system, where will be the position of center of mass? For two particle system, center of mass ekkada untundi? Near to the heavier body, and it must lie on this line only. Clear no ma? That's what we have studied in two particle system now. For a two particle system, center of mass must lie on the line which is joining these two masses, and it should be closer to heavier mass. Okay. Then what is the formula? Let us consider this axis to be x axis. Then x center of mass is m1 x1 dash plus m2 x2 dash divided by m1 plus m2. So this is the equation of center of mass number. And to calculate center of mass there should be a reference, no? Already we studied, no? Because center of mass is a distance. Center of mass is the position kada. To measure position there must be some reference. Which one shall I take reference here? I will take this body to be my reference, or you can take this body also, or you can take middle also, any point you can take. I am taking this body to be my reference. Are you able to understand? Because center of mass cannot be calculated without a reference. Moment of inertia cannot be calculated without an axis. Are you able to understand? Torque you cannot calculate without an axis. Angular momentum you cannot calculate without an axis. Center of mass you cannot calculate without a reference. Reference lekunda cheyalem kada. So this is my reference. Now do the calculation. Let us take this is m1 and let us take this is m2. Clear ma? So what is the mass of first particle? Mass of the first particle 2m. X1 means what? Distance of first particle from the reference. So from the reference, first particle is present at how much distance? 0 distance. So multiplied by 0. Clear now? Mass of the second particle? m2. So what is the position of second particle from reference? L. So L divided by m1 plus m2. So 2m plus m. Clear now? So therefore, how much it is? This is m, no? So m into L divided by 3m. So this is x center of mass. So m if you get cancelled, L by 3. Okay, ma? L by 3 means where, ma? Somewhere here, no? Total length is L. So L by 3 means somewhere here. Okay. So this distance I can call it as L by 3. So it means where is the axis? Axis is passing from here. This is the axis of rotation. Okay, arthamautundi kada? First of all, we have identified the position of center of mass. We have understood that it is present at L by 3. Clear, no? So from this center of mass, axis is passing and this total system will rotate. Now is it clear? So from the first mass, what is the distance of center of mass? L by 3. Then what will be this distance? L minus L by 3. So total distance is L, no, ma? L on L by 3, this is the remaining distance. L minus L by 3. L minus L by 3 is how much? 2L divided by 3. So that is the position of center of mass from second body. Are you able to understand? From first body it is L by 3. Now do the calculation. So therefore, angular momentum of total system, I can write it as angular momentum of first body plus angular momentum of second body. Because here two bodies are there. First mass is also a mass. Second mass is also a mass. No? So two masses are present. Why I am writing in vector form?
Directions.
Because angular momentum is a vector quantity. No? Directions also we should be careful. Are you able to understand? So total angular momentum is vector sum of angular momentum of first particle plus angular momentum of second particle. Are you able to understand? So I can calculate angular momentum in two methods. Okay, let us do in both the methods. First method. Okay, first method, angular momentum is equals to mvr. I can calculate in this method also. So let us calculate angular momentum of first particle, let it be L1. So can you say how can I calculate L1? Angular momentum of this particle is how much? So this particle, it is rotating about this axis, no ma? This particle din chuttu rotate avutundi kada. So therefore angular momentum L1 is equals to mvr. This is the first method. Mass of the particle 2m. What is its tangential velocity? I don't know. What is its radius? Radius means perpendicular distance is how much? Perpendicular distance is L by 3. Are you able to understand, ma? Angular velocity, is it given, ma? Angular velocity, is it not given in the problem? Angular velocity, he did not give anything, ma? So let us assume it is rotating with an angular velocity of omega. So add that in the question, ma. Rod's angular momentum is how much? Sorry, angular velocity is omega. Angular velocity of the rod is omega. Are you able to understand? Okay. So now tangential speed of this rod, do I know, ma? So let us consider rod is rotating like this. So rod will have some tangential speed, no? See here, I will draw the diagram. So consider this is the circle in which these two rods are rotating. This is first mass, this is the second mass. They are connected by a light rod. So center of mass is somewhere here. So this rod tangential speed is Vt1, tangential speed of second one is Vt2. So this distance is L by 3, this distance is 2L divided by 3. Mass of this one is 2m, mass of this one is m. So I can write figure like this also. Okay, ma? This is the axis of rotation. Okay, so they are rotating like this. So Vt means what here? Tangential speed only, no, ma? V means tangential speed only, no? So tangential speed, how can I calculate? What is the formula for tangential speed? Vt is equals to omega into r. Already we have studied. Tangential speed gide kada formula. Vt is equals to omega into r. So substitute here. So omega, angular velocity is omega, and r means perpendicular distance number from the axis. What is the perpendicular distance? L by 3 multiplied by again L by 3. Clear now? So therefore m L square omega 2 divided by 9. So 2 m L square omega divided by 9. So this is the angular momentum of first particle, first mass. Similarly you calculate for second mass also. Clear now? So second mass, angular momentum is L2. So L2 is equals to again same formula, mvr. Mass of the second particle is how much? Mass of the second particle is m, and its tangential speed is vt2. And what is the perpendicular distance? Perpendicular distance is 2l by 3. That's all. No? For second mass, perpendicular distance is 2l by 3. Clear now? But what is the tangential speed? Again, what is the formula for tangential speed? Omega into r. So omega into, now again what is the perpendicular distance? 2l by 3 multiplied by again 2l by 3. Clear now? So again what I will get? So m L square omega multiplied by 4 divided by 9. So that is the angular momentum of second particle. అర్థమవుతుందా ఎలా చేస్తున్నాము? Very simple concept. Okay. Now the question is, here I have written in vector form, no? I have written in vector form. Okay. If I have written in vector form, it means I should find out the directions also, no? Now can you say what is the direction of angular momentum of first particle? And what is the direction of angular momentum of second particle? Positive, negative. Abba, matalle. ఇంకోసారి చూడండి బాగా. So this is the first particle, no? R dash cross B dash. If I am assuming that it is moving in this direction, R dash cross P dash. Direction is in which direction? Perpendicular and out of the board. Okay. For this one, R dash cross P dash. This is also perpendicular and out of the board only. Are you able to understand? No? It means both angular momenta, they are in the same direction. If they are in the same direction, directly you can add them, no? Clear, no? So therefore, what is the total angular momentum? Total angular momentum is L1 plus L2. Now no need of writing in vectors because they are in the same direction. Okay. So therefore, write down. So 2 by 9 m L square omega plus 4 by 9 m L square omega. So total how much ma? 2 plus 4, 6. 6 by 9 m L square omega. So 6 by 9 means how much? 2 by 3 m L square omega. Okay, that's all. That is my equation of angular momentum. So have you understood why we have added them? Why? Because both angular momenta, they are in the same direction. Okay, so make a note of that point. What is the note point here? I have to write. Note point is that both angular momenta are in same direction. Okay, so therefore if I want to write in vector form, how can I write ma? So 2 by 3 ml square omega multiplied by k cap, because it is towards positive z axis, no? So I can write k cap. Okay, so this is the first method of solving this problem. So first method I have calculated by using which method? L is equal to mvr method. Okay. Now can you say how conservation of angular momentum? First question. If radius of earth is doubled without a change in its mass, so what will be the length of a day? Are you able to understand? So we know the radius of Earth is r, 6,400 kilometers. Mass is some 6 into 10 power 24 kg. Okay, mass is not changing. So just radius of the Earth is becoming double. Are you able to understand? Then what will be the length of a day? Length of a day depends on what? Length of a day ante day 10 meterlu unda 20 meterlu unda ani kaadu. Length of a day means what? What is the time taken for Earth to make one rotation? That is called as length of a day. Are you able to understand, ma? So this length of a day, it depends on angular velocity of Earth, no? It depends on what? Angular velocity of Earth. If Earth is rotating very fast, length of the day will be very less. Clear, no? If Earth rotates very slowly, length of the day will be very big. Okay. Now let us see how we can do this problem. See, ma. So this is Earth, whose radius is r, and this is getting converting into a bigger radius, bigger sphere, whose radius is 2r. Mass of this is m, mass of this one is also m, because he said that there is no change in mass, no? Mass is not changing. Okay. Now what will be the length of a day? That is the question. Okay. So what is the formula for angular momentum of a sphere? Sima, consider Earth is a sphere which is rotating about this axis. No? It is rotating about this axis. So what will be its angular momentum? Angular momentum will be I into omega. This will be the formula for angular momentum. No? I into omega, because this is a rotating body. Instead of mvr, I can use this relation I into omega, formula for angular momentum. Are you able to understand? Okay. Now here just radius has become double. Mass is not changing. Are we applying any torque here to increase the angular momentum or to decrease the angular momentum? Are we applying any torque? Torque we are not applying, no. Mass is increasing, radius of the Earth is increasing by itself. Okay. So therefore I can say torque acting on this Earth is 0. Torque is 0. We are not applying any force, we are not applying any torque. Okay. If torque acting is 0, then dl by dt also should be 0. No? How we got this relation? By analogy of Newton's second law. Do you remember? F net is equals to dp by dt. This is Newton's second law. No? Rate of change of momentum of a body is directly proportional to net external force acting on the system. Clear, no? Similarly, rate of change of angular momentum is directly proportional to net torque acting on a system. Clear? So therefore net torque is 0, dl by dt is also 0. dl by dt will become 0 in which condition? dl by dt 0 eppudu avutundi? Only when L is a constant. Okay, ma? If L is a constant, dl means what? Change in L. There is no change in L. Change in L is 0. So 0 divided by dt. 0 divided by dt will be 0. It means dl is not there. dl ledu ante artham emi? Change in L is not there. Change L lo change ledu ante L is a constant. That is the meaning of that. No? So if L is a constant, then I can write L1 is equal to L2. Initial angular momentum and final angular momentum, they are same. This is exactly what is called as law of conservation of angular momentum. Adhe kada law of conservation of angular momentum. If net torque acting on a system is 0, total angular momentum always remains a constant. So initial angular momentum, final angular momentum, they are same. Okay. And what is the formula for angular momentum? I into omega. So therefore can I write I1 omega 1 must be equal to I2 omega 2. I can write like this now. I1 is the moment of inertia in the first condition, I2 is the moment of inertia in the second condition. Omega is the angular velocity in the first condition, omega is the angular velocity in the second condition, omega 1, omega 2. Okay? Okay. Now what is the moment of inertia of this body? This body is a disk, no? Disk, no? Earth is a solid sphere, no? So what is the moment of inertia of a solid sphere? Solid sphere, 2 by 5 mr square. 2 by 5 mr square. Mass of the body is m and its initial radius is how much? R. So 2 by 5 mr square multiplied by initial angular velocity, let us call it as omega. Okay, let us call this one as omega, and angular velocity, let us call it as omega dash. Final angular velocity. Okay. So then I2 means what? Moment of inertia of same earth, but when radius is doubled. But mass is same, no? Mass is same. Formula remains same. So 2 by 5, mass is same. But what is the radius? Radius has become double. So 2r whole square multiplied by angular velocity also will change. If I value changes, omega also will change, no? Because total should be constant. I into omega constant ga undali kada, but I is changing. So omega also must change. Are you able to understand, ma? If moment of inertia increases, angular velocity should decrease, so that total angular momentum should be a constant. Total constant gane undali kada. So therefore 2 by 5m get cancelled, r square and r square get cancelled. So therefore can I write omega dash is equals to omega divided by 4. That's all, no? This 2 square, if it comes to this side, then omega dash is equals to omega by 4. It means the new angular velocity has reduced by how many times? Reduced by 4 times. Okay. It means earth is further rotating very slowly. Earth at మామూలుగానే చాలా స్లోగా rotate అవుతుంది. Now it is rotating 4 times slower. 4 times slower means time period will increase by 4 times. No? What is the time period of earth? 24 hours. So 24 into 4? 96. That will be the time period. Are you able to understand? Because angular velocity has reduced by 4 times. Time period will increase by 4 times. Proof ఎలా చేస్తాం? Sprcima. So we know that omega dash is nothing but 2 pi by t dash. That's all, no? And I can write omega is equals to 2 pi by t. This is how I can write, no? So substitute. Instead of omega dash, I will write 2 pi by t dash is equals to omega by 4. Omega is 2 pi by t divided by 4. 2 pi get cancelled. So therefore I can write t dash is equals to how can I write? I can write 4t. So t dash is equals to 4 into t value is 24 hours. So t dash is equals to 96 hours. Okay. It means earth completes a rotation in how much time? Earth completes one rotation in 96 hours. Okay. That's it. It means 48 hours will be day, 48 hours will be night time. So if time of this is this much, then I think all of you can get top rank in Neet examination. 45 గంటలు చదివితే ఇంకేముంది ఇంకా. Understood, Amma, how we have calculated? So by using which concept we have done? On this system, are we applying any torque, ma? Torque may act avatam. If torque is not acting, then angular momentum should be constant. So therefore I1 omega 1, I2 omega 2, they should be equal. That's all. Okay. No, I will explain you this question. Try to answer that. See what is the given question. So two disks of moment of inertia, I1 and I2, they are rotating with angular speeds of omega 1 and omega 2. So they are brought in contact with each other. Clear, no? It means that consider this is one disk, okay, which is rotating about this axis, and there is one more disk which is rotating about this axis. Okay, ma? So moment of inertia of this one is I1, moment of inertia of this one is I2. It is rotating with an angular speed of omega 1, this is rotating with an angular speed of omega 2. Okay. Now these two disks, they are brought together it means their axes, they are made to join with each other. Clear now? So if I combine their axes, then what will happen? Initially, their angular speeds are different. Angular speed of this one is omega 1, angular speed of this one is omega 2. Now if I combine them, what will happen? If I combine, what happens? Axis becomes common axis, no? It means both of them, they start rotating with same angular velocity. That is the meaning of this one. No? So if I combine their axis, rotating with common angular velocity. Clear, no? So then we are supposed to find out what is that common angular velocity and what is the loss in kinetic energy. So when I try to combine these two axes, in between these two axes there will be some friction. Rendu axes la madhya koncham friction untundi kada. So to overcome that friction, some of the energy must be wasted also. So what is that loss in kinetic energy? That also I want to calculate. Are you able to understand? So therefore, what is the point here I have to write? If axes are combined, then disks start rotating. Disk starts rotating with a common angular velocity. Okay, ma? So what is that common angular velocity? How can I calculate? Can you say? A common angular velocity ni manam ela find out cheyochu? Any idea, ma? So initial angular velocity omega 1, final angular velocity omega 2. I am combining both the axes, then both of them they start rotating with a common angular velocity. So based on which logic can I solve this problem? Anybody? Ela cheyochu? Sima, when I combine these two axes, when I bring these two axes together, I am applying any external force? External force ఏమన్నా అప్లై చేస్తున్నానా నేను? చేస్తున్నానా లేదా? ఇవి రెండు గట్టిగా కంబైన్ చేయడానికి ఏమైనా ప్రయత్నం చేస్తా ఉన్నానా? నో, జస్ట్ ఐఎమ్ బ్రింగింగ్ దీస్ టూ యాక్సెస్ టుగెదర్ అట్ వన్ పాయింట్. ఓకేమా? సో దేర్ ఫోర్ ఐ కెన్ సే నెట్ ఎక్స్టర్నల్ ఫోర్స్ ఈజ్ హౌ మచ్? 0. ఐఎమ్ నాట్ అప్లైయింగ్ ఎనీ ఎక్స్టర్నల్ ఫోర్స్ టు కంబైన్ బోత్ ఆఫ్ దెమ్. If net external force is 0, torque also will become 0, no ma? Net torque also will become 0. Because only if net force is there, then only net torque also will be there. Because torque relation we know, no, R into F. There is no net force, there is no net torque. If net torque is 0, then dl by dt also will be 0, no? Then I can say L is a constant, no? Are you able to understand, no? Torque formula dl by dt according to Newton's second law. Are you able to understand? If dl by dt is 0, it means L is a constant. What is L? Angular momentum of this system is a constant. So based on which logic I am trying to do this problem? Law of conservation of angular momentum. సుఖంగా పెరగడానికి అలవాటైనారు మీరు, అట్లయితే చదువు రాదు. ఓకే, సక్సెస్ సాక్రిఫైస్ని కోరుకుంటుంది. ఎంత సాక్రిఫైస్ చేస్తున్నారు మీరు అని. మేము రూపాయి సాక్రిఫైస్ చేయం, మాకు మాత్రం అన్నీ కావాలంటే కుదరదు. జీవితం అట్లా వర్కౌట్ అవ్వదు. ఓకే, సో దేర్ ఫోర్ వీఆర్ సాల్వింగ్ దిస్ ప్రాబ్లమ్ బేస్డ్ ఆన్ విచ్ లాజిక్ మా? లా ఆఫ్ కన్జర్వేషన్ ఆఫ్ యాంగులర్ మొమెంటమ్. ఇఫ్ నెట్ టార్క్ యాక్టింగ్ ఆన్ ఏ సిస్టమ్ ఈజ్ 0, then angular momentum remains a constant. This is what we have studied in the last class. Clear now? So therefore what I can say, therefore initial angular momentum is equals to final angular momentum, because net torque acting on the system is 0. Are you able to understand now? So initial angular momentum means what? Before combining them, angular momentum of first one was I1 into omega 1. This is the formula for angular momentum number. Angular momentum of second disk was how much? I2 into omega 2. Okay. Now if I combine both of them, what will happen? So both of them, they start moving with a common angular velocity omega. That's all. Clear number? So what is this omega? This is the common angular velocity. Rendu disk ఒకే velocity తో rotate అవ్వడం start అవుతాయి కదా, that angular velocity is omega. So for first one also same होगा, second one also same angular velocity. So therefore, what is the final angular speed? Final angular velocity is I1 omega 1 plus I2 omega 2 divided by I1 plus I2. So this is the final angular momentum. That is my answer. అసలు ఏమన్నా ఉందా ఇక్కడ సాల్వ్ చేయడానికి? Whenever a question is given, you have to identify question is based on which logic. ఇక్కడ ఏం అడగాలనుకుంటున్నాడు వాడు. Clear ba? So when you start combining the discs together, you are not applying any force. Torque also applied is 0. If torque applied is 0, then angular momentum will be constant. So initial angular momentum, final angular momentum, they are equal. Clear number? So that is my answer for first question. Then what he is asking second question. Okay. So loss in kinetic energy. So what is the loss in the case of kinetic energy? First of all, what is meant by loss in kinetic energy? Loss in kinetic energy means what? Clear number? It means initially kinetic energy will be greater, finally kinetic energy is lesser. So definitely there is some loss of kinetic energy because of friction. Okay ba? So because of friction there is some loss of kinetic energy. Are you able to understand? So therefore, how can I calculate the loss in kinetic energy? Loss is equals to initial kinetic energy minus final kinetic energy. That is how I calculate loss number. Loss in kinetic energy. Initial kinetic energy and final thesis, the loss in kinetic energy వస్తుంది. So what is the initial kinetic energy of the total system before combining? So half I1 omega 1 square plus half I2 omega 2 square. So this is the total initial kinetic energy, no? Before combining, minus after combining, both of them they start with a common velocity, no? So therefore half I1 plus I2 multiplied by omega square. Okay. So I1 plus I2, both moment of inertia I am adding, and what is the common angular velocity? Common angular velocity is omega square. Clear number? And omega value already I have calculated, no? Substitute here. So therefore loss in kinetic energy is half I1 omega 1 square plus half I2 omega 2 square minus half of I1 plus I2 multiplied by omega. Omega is how much ma? I1 omega 1 plus I2 omega 2 divided by I1 plus I2. Clear now? So try to simplify this one. So therefore loss in kinetic energy is equals to, so half I1 omega 1 square plus half I2 omega 2 square minus half of, so I1 omega 1 plus I2 omega 2. Okay. If you want to further simplify, you can simplify this. Are you able to understand? Is it clear ma how we have done the calculation? Very simple. So if you want to simplify, you can further simplify this one. See ma, here this is square, no? I forgot to put square here. Omega square, no? Okay. So therefore if I do this calculation, I will get half I1 omega 1 square plus half I2 omega 2 square minus of, so here one I1 I2, another I1 I2 get cancelled, so half of I1 omega 1 plus I2 omega 2 whole square divided by I1 plus I2. Okay. If you want to further simplify this one, you can simplify. So the final answer which he gave is loss is equals to half I1 I2 divided by I1 plus I2 multiplied by omega 1 minus omega 2 whole square. Okay, so that is the final answer which you should get. This question here. So now this is a rod which is in rest position about this axis. Rod is in vertical position. Okay, rod is in rest position and this is the axis of rotation. It means rod can rotate about this axis. Clear? So a bird of mass m moving with a velocity of v0, it is coming and striking this rod. At what distance? At a distance of L by 3 from the top of the rod. Clear now? Then after striking, the velocity of the bird has become 0. That is why it is falling to the ground. That is the data which is given now. After collision, bird drops to ground. It is falling to the ground. Clear now? So therefore, immediately after collision, a rod will gain some angular velocity. No? It starts rotating with some angular velocity. So what is that angular velocity? First question. And the rod, after some time, it will fall to the ground also. No? Rod will become horizontal. Okay. So when it is about to touch the ground, then what is the angular velocity of the rod? So these two values we are supposed to calculate. Okay. Now can you say how can I do this calculation? Okay, Seema. So what I will do is, I will take this total bodies as my system. Clear now? So bird and rod, both of them I will consider as a system. If you take individual bodies, for example, if you take a rod only, then on the rod, bird is applying force. No? Rod మాత్రమే మీరు తీసుకున్నారు అనుకోండి, రాడ్ పైన బర్డ్ ఫోర్స్ అప్లై చేస్తూ ఉంది కదా. సో దేర్ ఫోర్ ఐ కెనాట్ సే ఎక్స్టర్నల్ ఫోర్స్ ఈజ్ 0. ఓకే, సిమిలర్లీ ఇఫ్ ఐ టేక్ ఓన్లీ బర్డ్, on the bird rod is also applying force by Newton's third law, then also I can say external force acting and the bird is not 0. I cannot say. Are you able to understand? So what I do, I will take rod and bird as a system. Okay, ma? So taking rod and bird as one system. Are you able to understand? If I take both of them as one system, then total external forces acting on the system is 0. That's all. Nama. Idantha oka system ga తీసుకున్నాను అనుకోండి. So from the external surroundings, is any external force acting on this system? ఏమైనా యాక్ట్ అవుతుందా? No. So F external forces acting on the system is how much? F external forces are 0. Are you able to understand? If external forces are 0, net torque acting on the system is also 0. If a net torque acting is 0, angular momentum is a constant. That's all. Again, same concept. Clear now? If total angular momentum is constant, then I can say L1 is equals to L2. Total initial angular momentum and final angular momentum, they must be equal to each other. Are you able to understand now? So initially, can you say what was the initial angular momentum before bird was coming and striking? Okay, ma? What was the initial angular momentum? Initial ante eppudu before bird coming and striking, that is the initial angular momentum. Final angular momentum means after the bird has striken the rod, that is the final angular momentum. Clear? Initial angular momentum is how much? Initial angular momentum is possessed only by bird only. A rod does not have any angular momentum initially. Because rod is in rest position, its angular momentum will be 0. Okay. So which one I am taking my axis of rotation? This is the axis of rotation. No? About this axis, what is the angular momentum of the bird? Angular momentum of the bird is mvr. That's all. Or I will write separately. Okay, ma? So first of all I will calculate L1. Okay, only bird has angular momentum. Initially, which body is having angular momentum? Only bird is having angular momentum. About which axis? about this axis I have to calculate, because rod is also rotating about same axis, no? So you calculate angular momentum of the bird also about the same axis. Angular momentum cannot be defined without axis. Already చదువుకున్నాం కదా, angular momentum axis లేకుండా define చేయలేము. Are you able to understand? So therefore L1, so L of bird, so mvr. What is the mass of the bird? Mass of the bird is m. Velocity of the bird v0. So what is the perpendicular distance from the axis of rotation? Here what is meant by r? R is nothing but perpendicular distance from the axis of rotation, no? So this is the axis of rotation. From here, this perpendicular distance is what I require. This is r value here. How much it is? 2l by 3. So total is l value, no ma? So from l, if you remove l by 3, then what is the remaining distance? R is equals to 2l divided by 3. Okay. So multiplied by 2l divided by 3. So this is the angular momentum of the bird also, angular momentum of total system also. Okay. Now L2. L2 is what? Final angular momentum of total system. Okay ma? So here angular momentum of bird is this much, angular momentum of rod is how much? 0 initially. Finally angular momentum of bird is 0. Because after striking, bird is going into rest position, no? Rod to strike అయిపోతూనే bird silent అయిపోయింది అనమాట. Its angular momentum has become 0. Okay ma? So angular momentum of bird is 0 finally. But rod starts rotation, no? Rod rotate avadam start అవుతుంది కదా. So angular momentum of rod is how much? So I can write I into omega. I into omega is one formula for angular momentum, no? Okay. So angular momentum of rod, I value. What is the moment of inertia of the rod? Rod moment of inertia. Rod moment of inertia is ml square by 3 if it is rotating about one axis. Moment of inertia lo chadukunnam kada. When axis is present at the middle, then it is ml square by 12. But axis is present at one end of the rod, no ma? So its moment of inertia will be how much? ml square by 3. So what is the mass of the rod? 3m. M L square. What is the length of the rod? L only. So ml square divided by 3. Clear now? This is the angular moment. This is the moment of inertia of the rod. Multiplied by its initial angular velocity. I don't know. No, let it be omega. So 3 and 3 if I get cancelled, then angular momentum of the rod is of the total system is how much? ml square multiplied by omega 2. This is also equal to L2. What is meant by L2? Final angular momentum. Clear now? So therefore I can say that L1 is equal to L2. So initially only bird is having angular momentum. How much? mv0 into 2l by 3 is equals to, finally only rod is having angular momentum, and it is how much? ml square multiplied by omega. So mass and mass, L and 1L get cancelled. So therefore omega is equals to 2 by 3 V0 divided by L. That's all now. So that is the angular momentum of the rod just after collision. Okay ma? Just when the bird strikes the rod will have this much amount of angular velocity. Okay, that's it. When bird just strikes the rod will start rotating with this much amount of angular velocity. Clear now? So but with this angular velocity, rod starts rotation, no ma? So this is the rod initially, and this is the axis of rotation. So bird starts falling. It starts falling with an initial angular velocity of 2 by 3 V0 divided by L. This is the initial angular velocity. So after some time what will happen? Rod will fall to the ground, no ma? Rod will fall to the ground. Are you able to understand? And here let angular velocity be omega naught or omega dash anything. Omega, this one we have taken omega naught, no ma? This one let us consider it is omega dash. Okay. What is this omega dash? Final angular velocity of rod. Final angular velocity of rod when it is about to touch the ground. Ground ku touch ayetappudu inta angular velocity untundi. Angular velocity definitely increases, no ma, because when rod starts falling down, external force is acting here. Gravitational force is pulling the rod. No? So because gravitational force is pulling the rod, definitely the angular velocity of the rod increases. Ekku velocity to the ground nu touch avutundi. Now can you say, how can I calculate this omega dash? Omega dash value, how can I calculate? Anybody? Huh? How? Torque produced. But torque is not a constant, my dear. By using torque also you can calculate, but torque is not a constant. No? Okay, ma, torque R into F. Angle between R and F is continuously changing. Torque is not a constant. With that method, it is very tough. Any other method? Initial angular velocity is this much. Final angular velocity, how can I calculate? Ela chestam. See, already we discussed that law of conservation of energy. This I can use, no? Okay. ఇంకా మనకి ఏ దారి కనపడినప్పుడు గోదారే మీ దారి అని చెప్పినాను కదా ఆల్రెడీ మీకు. సో వెన్ యూ డోంట్ హ్యావ్ ఎనీ అదర్ మెథడ్ ఆఫ్ సాల్వింగ్, దెన్ లా ఆఫ్ కన్జర్వేషన్ ఆఫ్ ఎనర్జీ ఆల్వేస్ యూ కెన్ అప్లై. ఆర్ ఏబుల్ టు అండర్స్టాండ్? సో వాట్ ఈస్ దట్ వన్? టోటల్ ఇనీషియల్ ఎనర్జీ ఆఫ్ ద సిస్టమ్ ఈజ్ ఈక్వల్ టు టోటల్ final energy of the system. Now if you see here, on this falling rod, which force is acting? Only gravitational force. And gravitational force is what kind of force? Conservative force. Ante conservative forces maatrame act avutunnai kada. Okay ma? So only gravitational force is acting. Okay ma? And gravitational force is what kind of force? It is a conservative force. Okay, because it is a conservative force, I can use the law of conservation of mechanical energy, no? K1 plus U1 is equals to K2 plus U2. In which condition I can use this formula? When only conservative forces are acting. Are you able to understand, no? So initial kinetic energy of the rod. Initial kinetic energy of the rod. Kinetic energy means here translational kinetic energy or rotational kinetic energy? Only rotational kinetic energy about this axis. Are you able to understand? Ma? So half I omega naught square. Initial angular velocity omega naught square. Okay, ma? Initial potential energy, it is not zero. See ma, for this total rod, total mass will be concentrated at its center, no ma? This is the position of center of mass, no? Let us take this point to be our reference. Ground I am taking to be my reference. Without reference I cannot calculate potential energy, no? This one I will take it as zero potential energy reference. It means this is the point of zero potential energy. So from this point, what is this height? The height anta? L by 2. Clear now? So potential energy formula mgh only, no? What is the mass of the rod? 3m. Mass of the rod is 3m. mgh. What is the height here? Height is nothing but L by 2. Clear now? So 3m into g into L by 2. So this is the initial potential energy of the rod. Understood? No? This is equals to K2. Final kinetic energy of the rod. When it is about to touch the ground, then what is its angular velocity? Omega dash. Clear? So half I omega dash square plus final kinetic energy. Final kinetic energy is 0 because now center of mass is present here. No? Irad ila kinda pannappudu center of mass ikkada untundi. It is at same height of zero potential energy, no? So final potential energy of the system is 0. Clear now? Plus 0. Now just calculate omega dash value, that is my required answer. That's okay. What is I value of the rod? I value of the rod is again same, ml square by 3. ml square by 3 only, no, when rod is rotating about one axis. So mass is 3m, L square divided by 3. So it is ml square. This is the moment of inertia of the rod. So substitute all the values, calculate omega dash value, that is my answer. So the answer which you should get is square root of 4 square root of 4 V naught square divided by 9L square 9L square plus 3G divided by L. So this is the final answer which you should get. Check whether you get this answer or not.